welcome Lukáš on stage.
Hello, hello, do you hear me? Okay. Good to see you, so many faces there. Hi, I'm Lukáš. I'm solution architect at Uplifting and chairman, because of you got a board. I'm currently more than 15 years of programming, so mostly in these languages, probably you know all of them. And during my career, I made, I would say not so many, but many mistakes, right? And I think it would be fine to share some of these mistakes with you so you don't have to repeat them, but it's probably up to you, right? So let's do it. Anemic model. We know anemic model. Okay, 3 hands. Who knows Martin Fowler? Okay, that's better. So it seems that you don't read his books nor blog, right? Okay. So here is typical code. Don't be scared about the lines. On the left side, you got classic entity, order. And on the right side, there is an order service, right? You don't have to care about the fields. It's something I would say usual stuff, ID and amount and status and so on. On the right side, we got 2 methods, create an order and return an order, right? And if you look closer, you see that there are some validations, right? And after validations, the model is created and saved, and then some business logic happened, like sending the mail. But I don't like it. Any thoughts why? So the validation is part of, or okay. Yeah, that's true, but that's not the point. The point is that there is no behavior. That's just data structure. It's just a table. Your table in your relation database. Right. And if you look closer to the return order method, you see that I gather order from the database, right? If it's not there, I'm throwing some exception, right? Probably some entity not found exception could be. I just use illegal argument just for an example. I check that the status is correct, right? And if it's not, I'm throwing an exception. After that, I'm setting some attributes to some specific values I want and sending the mail, right? And at the end of this workflow, I'm saving the order into database, right? But there is no behavior. That's classic procedure programming, right? If you look on the order class, you see no behavior, right? Okay, there are getters and setters because we love them, right? That's the encapsulation thing. Or maybe no. Or you can do it better, right? So you can do proper domain modeling. So you decompose your model into smaller structures or smaller classes, right? So instead of directly checking the status of my order, I invented a new class, returned order, and I extracted this logic into separated class, order returner. Don't hate me for naming, I'm not good at that. The code is the same, but the whole point is that I don't have to check the status. Because I told the repository, give me the new order. Yeah, there's a software issue, not on my slides. So after a few seconds, it'll be there and it's there. Yeah. So I told, give me a new order. And I passed this new order into order returner. But this order returner is expecting new order type. Right? Do you see it? I baked the business logic into my code. Now code is the documentation, not this. My favorite one, hidden dependencies. Okay, I got a class like purchase, so there's a few fields, and there is a static method, create new one. just like for the purpose how the new one could be created. And if you see how this method is being called, what's wrong there? Ideas? How do you test that? Okay, let's imagine that you are not on a language that allows you to use monkey patching, like Python, Ruby, or Node.js and something like this. Okay. Yeah, I like it. 2 different timestamps. You may say, okay, but we are purchasing probably shoes, right, from your eShop favorite. It doesn't matter. Okay, it matters in systems. If you are, for example, writing Deutsche Börse code, so it matters on milliseconds. That's the first thing. The second thing is that how you are going to test it that? You cannot, because the value is still changing. Because the side effect, getting the now is, sorry, it's not side effect, it's impure function, is baked into the code. So let's make the dependency explicit. Let's create a method that creates a new instance of the purchase, but expecting some function. You can see I'm using supplier, which like in Java means like a function that it has no argument and returning offset datetime. And also I lift up the warranty in days parameter to compute that. So we can be sure that our business logic and the computation of the warranty wallet at a parameter is like, properly computed. Little hint, you can do it even that better. What happens if I like misconfigured my warranty in days into, negative number? That's bad, right? But it's something else. Okay. You know what is a module? Like every time I hear, okay, we got a system, there are a few modules, right? And the programmer shows me, like just a file. But if you visualize that like file. Hello. It seems that the hardware is not with us today. No problem. If you visualize that into a graph, you will see that all these like, let's say modules, so-called modules, I would say files or folders with files are calling each other, right? But module is usually defined as something which is like, with a high cohesion and low coupling with other stuff or other modules. So let's design a new system using our favorite microservices, right? And we have order system. So we have like order taking, let's say domain or microservice, and there is our order module, order entity, which is the aggregate. So there would be order items, but it's not important. And we also have our shipping module or service. And like there is obvious dependency, right? Because when the order needs to be shipped, you need to get an address, and address is probably part of the order, right? But if you create like system like this, you have like direct dependency between like, inner entities, between modules. So like these two modules are tightly coupled. Because every time you need to change the order, you need to recompile or change the shipping module. And that's bad. And you should feel bad for that. The way out of that is like, first thing is creating like something, let's say like data transfer object that would be exposed from that module. So that's the order public. Don't blame me for the naming. And like now, order public is not tightly coupled with our inner entity, because that would be mapped when the data would be leaving the module. So in our shipping domain, we would be depending on the order public, which is something like API for us. So we have like free hands to changing the order and order item and so on. Yeah, messaging equals decoupling. I heard that a few times. Like typical thing, right? You start to create a microservices system, but you find out that you need to get a consistency there, right? So you start thinking, okay, how can I ensure the consistency in distributed system? There are usually two ways, sagas and two-phase commits. But okay, your distributed system and you need like ensure integrity in the system. But it means that you don't have like, your services aren't decoupled because they are coupled together if you need to ensure the consistency in that way. So I created a Wien graph to display like how messaging and decoupling, are related together, and that's it. I'm not kidding. The messaging is just a way of the communication. Could be sync or async. We know that, right? But there's like nothing about the coupling or decoupling. It's just way of the communication. Okay, my favorite. Email class. Please don't blame me for the regular expression. I'm not good at that. And just want to show you like how simple mail class would look like. So as you can see, I'm using a factory pattern because like the constructor is private, but that's not an important. The important thing is that there is like function that like, validates the input, and if it's like valid, you get an email instance, right? It? Because what I'm saying, if you see this annotation, I will return an email type, right? Is that true? It's not, right? Yeah. Because I'm throwing exception, because I am lazy, so I'm throwing runtime exception, so I don't have to write it into, like the interface of that function. So there are like two ways how to get rid of that. Like first thing is using checked exceptions. I know that like everybody probably of you hates checked exceptions, right? Because it's like painful because you have to care about them. But the point is that if I am using checked exception, I want to tell you, okay, I could return A, either B. And that's the point. I want to be explicit what could happen. Yeah, this is like Java example. So for that reason, I use a check exception. If the Java as a language would support either type, you can model it as either type, for example, F# or something like this. It depends on like your favorite language. Misleak API. Okay, order again. So I had an order class, and there's a like method, so it's a rich model, right? I got the method return order, right? And when I check the status, and if it's not like my expected one, I throw an exception. How many of you seen like this code? How many times? Any of you? Okay, see, okay, Robin, nice, I like it. But like, what's wrong with that? The class is lying, right? Because you cannot return order every time. So let's lift this model into more modulus. I would call them fine-grained modulus. So you explicitly saying, okay, from new order you can return like returned order. So every time when you like pull the return order from the database, you cannot call return order on a returned order because it's not possible. The API would not allow you to do that, as you can see. Distributed monolith, right? Has anyone worked once at least on a project where you need to, synchronize deployment of the services, microservices system. Okay, see six hands, right? Yeah. It's a smell, right? It should be like something like independent. They told me that when I read the book. How is it possible, right? Or another symptom is like even like simple change, you need to update 3, 4, 5 services, and you need to release them at once. It's my beloved feature of that system. And how to get rid of that, right? Because you just create a distributed monolith. That's it, and you cannot scale it anyway. Okay, this is a hard one. So you can try to redesign it again. So you either merge more services into one service, maybe. Maybe it's a good idea because you split it at the very beginning and it was a bad idea. So, it's evolution architecture, so we are changing the architecture. Or you do proper decoupling because maybe you identify like the edges between the services that could be, cut and, but this is the hard one. How many of you had heard that we need to use Kafka for our next system? Yeah, it's my, like, Kafka is my favorite buzzword for the last 10 years because everybody want to play with Kafka, right? Because it's so super fancy, distributed, highly scalable, whatever, something, whatever. I worked on a system when like missed configuration prepared something that when you read the message from the Kafka, you lost the message when the consumer thrown an exception. And that's bad if it's transactional service, right? My point here is that like when you are starting something new, even in domain, you understand, for example, fintech domain or something like this, start with something small. I would suggest go with monolith. Monolith with decoupled components internally. Document that. Where are the the interfaces? Make them explicit. And after after a few months, maybe years, maybe never, you can go fully to the microservices and go to the distributed system. Even if you want to design an asynchronous system, you don't have to involve Kafka at the very beginning. And I'm not talking about that like running Kafka for more environments is super pricey. So maybe go with Rabbit, or maybe go with nothing, just like for internal purposes, use something lightweight. And if you would have there some bottleneck or something, introduce Rabbit or ZeroMQ or something like this. Have you ever heard about open close principle? That's the better one. This is like a class that allows you to connect your favorite virtual private network. It's being, prepared for the two type of protocols, right? Simply connect and disconnect, right? But for some reason, I like it. Any idea? Sorry, two switches? Yeah, two. So it would be better if there would be one. I don't think so. Sorry? Good one. Or maybe simple polymorphism, right? That could either would work, something like this. But the whole point is that I don't know how it's possible that like so many times I see that like programmers model things as enums, because at the very beginning you have like 2 or 3 values. Yeah, I got used to it in like languages like Java or Kotlin or something like this. But like somehow after like TypeScript introduce enums, also TypeScript programmers like they do that for some reason and try to add like third protocol. And I just highlighted like 2 spots, right? But in code base, there will be probably 5 or 10 spots of that, because there will be probably some UI that you generate a list of it, that there will be some controller that we validating the input. So we would reuse the enum itself like so many times. But that's against the single point of change, right? So I would suggest to use, for example, polymorphism. So you create an interface and that's it. So you can simply add new protocol without even touching the controller and the code that, like, work with the with the handling the connection itself. What I would need to do is just like create new implementation of the protocol and register it into factory. For the simplicity, I put it into controller, but it's a probably bad idea. What you can do in your framework using dependency injection or configuration, so it would be in JSON, XML file, doesn't matter. But like that's all. So that would be just only place where you put your new supported protocol. And that's it. This is like the real code. Oh, sorry, from the real project. Yeah, and the last one. For some reason, I would say very good reason, like last 5 years are so many programmers being passionate for functional programming, and we think it's a good idea, right? Because we heavily overused object-oriented programming in last 2 decades. But the thing is that I heard like the reason is that, okay, OOP leads to the more complex code. That's not true. That's like bad modeling of the domain leads to more complex code. And I'm saying that as someone who worked for 6 years full time as a Clojure programmer and probably seen the worst Clojure code bases in the world. It leads to the structures and anemic services. Yeah, that was the first example. That was very functional, right? Because you separated code and the data, and we like it. We like it in a proper way, not in a bad way. And I often hear that, like, I'm using map and filters, so I'm doing functional programming, right? Nah, you don't. I would say that using low-level for loop is still functional if you do the iteration in like one small closed function. It would be still functional because you are not touching the outside of the scope. And I would say that object-oriented programming and functional programming are complementary. And the reason is that because we like encapsulation, right? There are getters and setters. Nope. Encapsulations are usually in your code base the service layer, right? There will be create order, return order, and so on. This is the encapsulation about the logic. But if you would be writing that code in like functional, purely functional language, you would end up with module that would be probably called API or whatever, and that would be create order, return order, and so on. And that would be encapsulation around the logic, but not encapsulation around the table or something like this. Stateless. We love stateless stuff in functional programming. But you can do same thing in object-oriented language like a Java. And I saw you I would say 5 examples of that. And you want to do that. You know why? Because it's much easier to test it. Another thing, have someone of you heard about separating side effects to the edges or pushing side effects to the edges, separating side effects from the the business logic, 1 hand, 2 hands, 3 hands? Yeah. And I have to say that I read that in old object-oriented book, not in the functional one, because it's like concept of modeling the problem. It is not tied together to Java or or Clojure or F# or Elm or stuff like this. And it's being called sandwich architecture anyway. And I totally recommend you to check that term At the end of these slides, there are references, so you can directly follow the links. And if there are few of you that would like to start doing functional programming, and however you are like on your, let's say, career using non-functional based languages, it would be pain. And I recommend you to try pure functional languages like Clojure, F#, Haskell, or Elm, or something like this in your free time to see how this works. Because I've tried, I've been there. I tried. For example, in Python, it's not possible. They lie to you. If they say, okay, you just download func tools and it will work, it's not. The language is not prepared for that. So it will be pain. And small example that you can model same thing in totally different ways, right? On the left side, we have user factory in our beloved Java, right? So in constructor, I'm taking again function that returns date time, right? And there is one method that accepting username as a string, right? On the left side, there's a Clojure code. Don't be afraid about the parents. I would say it's pretty readable. So there's a create user function taking 2 arguments. Clojure is dynamically typed, so there is no strings and it's offset date time and so on. But it's returning a structure where it created at and username are the fields. When I create a new instance of our user factory, I'm baking function that returns offset date time, right? Does it make sense? Okay, it's probably too late for the coding, right? On the left side, sorry, it was on the left side. On the right side, I'm using function being called partial. We just bake again the function of set datetime now into our create user. And it gives me new function that takes just one argument, the last one, the username. So if I call this class with one only function, create, and my new function called factory, I get the same result, and these codes are same. And I would say both are same in a way that both are not pure, but because there is impure function now, but there are side effects. There are no side effects and easy to test, and functional programming in Java. So there are all of these 10, let's say, anti-patterns. I would say more than half of them I've made myself. So I wanted to share with you, so you don't have to make them again. Maybe it's up to you. And final thoughts. What you should take from this presentation is just to stop and think and design before start coding. Because for some reason, I saw that many programmers are just read it the task in Jira, barely create database schema, and just directly go and start coding. Yeah, and after 3 main days of coding, you end up and you are pushing your merge request right to your GitHub or GitLab, and you get the feedback from the team. So you spend another 2 days of refactoring, and it's a waste of time. So I think you can share some time and go some fancy events like this. And my architecture advice would be thinking about domain and modeling about domain problems without thinking about the infrastructure details. So model your systems. It doesn't matter if you use Kafka or Rabbit or something like this. Obviously, if your system is plugin for Redis or Rabbit or Kafka, okay, makes sense. But if you are working with classic information systems, model them without these low-level details, I would say. So thank you for your time, and I'm looking forward for some questions, and there are some links and maybe interesting books I would recommend. So I guess it's a time for Questions? So, yeah? Okay. Okay, first question. Imagine I deserialize my connections from JSONs. Can I survive without the enum switch? Sure. Sure. Because if I go back, it was like enum stuff, right? It's not a good thing right now. Yeah. Sure, because like if you see the render connector list, I'm getting all types from the factory, so I can validate these JSON against that. I would say, or you can like tweak the code that would be allows you to get all the needed data from the connectors. So I hope I'm answering your question. If not, just like speak up. Yeah, go ahead.
Let's say that I have a polymorphic class and like one superclass, and I serialize these like child instances in a database in a like single table, right? And I need to now extract them and generate these instances. So I typically I will have like a switch case based on some type to call the constructor of that service, or what's the better solution? And I think this is where the question was heading.
Like again, I thanks for the question. I would like from top of my head, I would go with the factory pattern. So I would register constructors that could be again classes or just functions that will be registered to some specific type. So when you read like your model from the database, there would be probably a column that tells you, which type you are getting on the row, and you would call that, function that is registered for that type. That's what I would do, and I would say the code would be almost same as here. But maybe I'm like, got wrong your question. Okay, welcome. So would you pass a timestamp as a parameter in a language where you can mock time? That's a good question. It depends. my last answer is because if I go back to for the code, was probably here, but was below, right? Sorry. Yeah, it was. Nope. What was the last one? Nope. Yep. Yeah, the last one. Yeah, right. Yeah. Yep. Here. Yeah. Okay. Like you have like two options, right? Like first thing is that we request here a function that is impure and returning, the offset datetime. There, the function could be pure actually, but I'm like expecting that it's impure. So I'm making my business logic or my business logic class or function again impure because I'm calling function that is impure. What I could do is that I could accept like just the value, and that's possible because, for example, I can imagine that during one HTTP request you want to have like all the timestamps be equal, right? That's possible, and there's super valid case for that. So you can mock, so you can inject, and again, what I would probably do, I would eject again the function, but the function would be constant in the scope of the call. So it depends what do you need, but you can mock time. If I hope that mock means just passing my testing function as a dependency, but not monkey patching. So have I answered your question, Mr. Bendover? Okay. Okay, the last one. Why is an anemic model antipath in OP, but in FP, everybody loves data and behavior separation? But anemic model is something which is not related to OOP nor FP, because I would go back for the first example. And the point is, the point is that even if this would be written in Clojure and there would be just a return order function accepting probably 3 arguments, this function would be still like, anemic. So what I would rather introduce would be like, again, more fine-grained order types, and saying, okay, this return order function, the function that does the business logic, which is in the rectangle or rectangle, I would say I expect a new order, no other type. So this is like I'm modeling the business rules. I'm modeling this assert of the status into type, because we use statically type systems, which is makes to say, okay. Another reason for this would be at the the very bottom there is a send order return function being called, right? And if I write code like this, you can pass here whatever order you want. And if you check the type system of that, you see that like the return reason and return add are optional, which means that in send order returned, I would need to unpack these values, which is silly, because if I'm sending order returned mail, right? I know that these 2 fields would be filled, something like this, right? So I can say that like send order is expecting the return order, and I'm sure that I get the correct data structure. That's probably the second thing. And the third thing is that how can I ensure that return add a return reason are both being set? The data model as it's written right now is not saying that. I'm just saying that, okay, I can like set just return add without the reason, or maybe just the reason, and setting the status, and it would be totally valid code, right? But if I introduce like this type of like fine-grained models, I say, okay, if you want to return order, you need to give me these 3 values, and I'm fine with that. So it's baked there. So if you like onboard someone new or someone else from the other side of your team who's not working with it, like functionally, like it eliminates the misuses of that function, or maybe the bad understanding of that, and so on. So Ben, have I answered that? Yeah. Okay. Any more questions? Done? Okay, so thank you for your attention, and enjoy the rest of the evening.